the call of SCI-Arc. All right, now you can hear it's going on. I realized tonight when I was getting ready to talk that the last time I think I spoke out in the main space was I think about 5-6 years ago. And I guess ever since then, usually in the intro class, most of us introduce our work there, and most of the faculty really haven't been speaking for a long, long time. At that time, I guess it was around 75, 76, I had completed 10 years of what I always felt was probably the more important body of work that I had done, and had felt that it had come to a head and a completion, and actually presented it that way. And I think I even made a statement that night that my next piece of work was going to be a mobile or a rec home kind of a thing. That's one of the statements that I think I've made in my life that I haven't been able to produce yet. I thought when I had the Advanced Technology House to do that it would be a good opportunity. The ones that I did prior to that, the studies seemed to be so archaic that I couldn't get myself really up to do that. Anyway, through the last 4, 5, 6 years, most of the work that I've been doing has been in a different vein. It deals with form probably somewhat differently, yet it deals with many of the same principles that I've always worked on in my work. The energy issues, of course, are incorporated, and I'll get into that a little more later. Probably the emphasis of my talk tonight will be more on form and energy than on humanism, even though probably in my own priorities I would put humanism first and probably put the form and energy behind that. It's just that I think any architect should have that as their top priority, and I feel that I think most architects feel they do, that they are dealing with human beings, that they are trying to solve those problems, and that they try to solve them in the best manner possible. The form energy thing comes from really a different point of view. I think most of us realize, and I think you probably realize after the talks that you've heard, that energy is really a consideration that's more like structures or environmental systems. It's something that should be, in my opinion, just a part of anybody's thinking. And what forms result from it usually are related to the total process, and on particular sites and with particular clients, special considerations come forward. And so last week, those of you who saw Rob Quigley see the way he deals with energy and form, which is quite different than I do, yet he does it in a very serious manner. His forms are more sympathetic with many people who don't even consider it an issue. So in my case, I still have dealt with architecture and particularly housing much the way I have for 30 years, and that's I still have felt that we're in a special climate zone in California. Most of my work has been in temperate zones, and I tend to want to open up the house as much as possible. I have not dealt with enclosed spaces. My spaces have always exploded, and my processes are additive rather than subtractive. And therefore, when the energy problem came about in '74 and the prescriptive standards came to California, I had to really do a total reevaluation, which I'll go through with you in a few minutes. Many of you have seen it before. Some of my material that you'll be seeing obviously has been seen before too. The other thing that I'd like to say tonight, and that's, I think the last time I spoke, for some reason, I think I went to about 11 o'clock, which was terrible. I think the only one who ever spoke longer was Terry Glassman. I think that went to about 11:30 one night. And so tonight I have just one tray of slides. It'll probably be a fairly short, concise talk. Our humanism can be discussed over in the gallery afterwards over a few glasses of wine. That's one way we get more people out now. We have the wine openings afterwards, and the work that's up is Glenn's and Rob Quigley's and mine, and that'll be for any of you who have not been to the gallery. I think there are a few people that I don't know from before. It's just, you'll just follow the crowd out and over there. I also was sorry that I missed Rob's lecture last week, or his talk, and I saw a little bit on the videotape as we were coming in, and I know he led off with the comment that with most architecture today, the staff works very hard, turns out a great deal of work, and the principal always gets all the credit, and I think he said, and he's going to keep it that way. Tonight, a lot of my staff through the years is here, and if I can, and I'll try, to give them credit where credit is due. Much of the drawing work it comes from people on staff. In many cases, their work has been very helpful in development and also in carrying it through further. Again, in general, most of the, particularly in the housing area, most of the beginning parts, the ideas, the concepts usually come from me, and sometimes many of the basic plan sections come from me. But then in any piece of work beyond that, there's a great amount of development, and there's a great amount of assistance that makes the work, in my opinion, a better piece, and also something that grows and develops as you work on it. So I think with that, I think I'll start the slides and we'll go from there. I had it on the first one, I think. I guess that's all out of focus, isn't it? This is just a composite of some of the work that has been done in the office over the last half a dozen years. And I'm just putting it up for starters to show the various forms that come out of the same kind of thinking as it relates to in response to special energy conditions, special site conditions, and the way I concern myself and deal with these kinds of issues. I'm not what you call a technical expert at all in the solar area or in energy areas. I have some attitude about the concepts. I understand them in their basic way. When I introduce them into my architecture, I do it in a way that I feel is more of a conceptual attitude, and then normally work with consultants to go further. A great deal of the work that is here is unbuilt work, unlike most of the work that I've done over the first 25 years. A great deal of this, some of this is still to be built, some of it's in construction, and it's at various places, and some have been put aside not to be built at all. So anyway, this is just a body of some of them that I will go through further as we get going. And I got the non-working changer, like everybody else that's been speaking lately. I need somebody on the advance. We got what do we got? 8 projectors here, and every week that I've been around, we get the bad one up here. Can I get a change? I don't think you're going to be able to read this very well, but I'll explain what it is. Can I? It needs to be focused too. Okay. Okay. Got that one. I think Roger just likes to come out front every week. Okay, huh? Okay. Yeah, that's going to work. Okay, and that's even a bigger slide. Okay, in '74, when the prescriptive California standard took place, which was one of the early ones, and always amazed me. I just came. We were away for last week in Quebec, Canada, at a association meeting of schools of architecture, and you know, there the weather was about 10 above, 15 above, and everywhere you go in the east, the heat is always just horrendous. Everybody keeps their heat up, it seems to me, about 80 degrees, 85 degrees, and it's always so warm, and they use so much energy, it seems like, in the east compared to what we do out here. And yet, when energy became a problem in the early 70s, California was one of the first states to set up a prescriptive code. And that code at that point in time said that you can only have 20% of your floor area in glass area. Well, that was a pretty important prescriptive standard to me because my glass areas were usually somewhere anywhere from about 45 to 80% of the floor area. So I was about 3 to 4 times what they were prescribing. Yet at the same time, I couldn't believe that in the temperate zones, particularly those along the coast where I do a lot of work, could possibly be that much worse than the closed houses that were the conventional houses. So before I decided to follow the prescriptive code, and I guess that's sort of my way of being anyway, I don't like standards that I don't understand, I decided that I would do a study of 14 of my houses and about 5 conventional houses to really see how they used energy, not you know, so that I could work with it. And so I asked these clients and these friends in areas that were in similar areas to send me their gas bills and also their electric bills over the year of 1975. And I took that data and charted it as it's shown here, and I charted the square footage. I charted the square footage of glass surface on every side of the building. I took off all the BTU loss as a column. I then looked at the floor area to glass area ratios. I looked at volume to surface area and so forth, all of the factors that are supposed to be important. I looked at what kind of appliances they used to see if that made any difference. I naturally took how they had insulated their places and charted all of this and then compared what I found. The 2 red lines, which I'll go through further, are 2 houses, one of mine, which should have proven out to be very bad in most cases, and another one, a conventional one, down below. And then if we'll give me the next slide, I've got it here, and we'll look at those a little closer. The house that I'm talking about on the top, I think you can probably read these figures now, show the penthouse, and the figure 1068 that's their gas thermal unit use during the year total, and on this one down here it's 1864. The square footage of the houses are 2692 to 2252, so this is a smaller house as well. The glass area ratios are 0.22, which is fairly close on this one to what the standard was going to be, and on the one up above it's 0.77, which is, you know, way beyond that factor. The other thing that's very strange on this one is the surface area to volume is way off on. I mean, in this one again, I think I think my number was 10.12, and this one was 8, and again. What happened was that this one proved to be a much more energy efficient from the standpoint of real gas consumption. So what I expected to find, I didn't find at all. I mean, it really surprised me what I found through this process. Other houses like this one was also very energy efficient. It was 1578 on a 3,400 square foot house. Conventional one, 4719 on 3456. Well, I don't want to dwell on it over and over and over, but what I did find correlated was really one factor, and that was that the insolation factor, the idea that any of the houses that were really facing south, southwest, southeast, primarily their glass areas were on those faces that had fairly good volumes of internal volumes, were quite energy efficient because of the way they worked. And in a house like this one, this one here of mine, the Pregerson house, which is not a very large house, it's 2,600 feet, the same as the one above, was a high energy user at 4,100 GTUs. And that was because it's primarily north-facing glass. So my conclusion, even though I know that it isn't the only factor, but as I looked through my whole charting, it seemed to me that it was more important the shape of the house, the type of overhangs, and where the glass existed. So from that standpoint, then I wasn't really willing to move backwards to punched windows again, and I continued to then, in all my work, justify it by calculations with the building department and move through the process that way. So all of the work, therefore, that followed, I had to devise a method, whether it be additional solar collecting or whether it was passive, to counteract what the prescriptive standard was. And in most cases, in all cases, they accepted those figures, and that's what most architects who are interested in the energy issue have done. This was the penthouse that I was describing that was completed, prior to the energy standards, and this is the one that proved to be the most efficient of all the houses that I did. And what I realized afterwards was that we had actually added a second layer of sunscreen, which was really, at the time that we designed it, was meant to be protection from the sun coming in and during the summer. And it was a double glazed area so that people who were on this canal could look out. What it proved to do, I'll show you in a section in a minute. This is where you can look out through the second level of glass. But in analysis later, we realized that we had actually created a pretty good heat trap, that the wind would blow actually on this face. You would get less heat loss at this point. We were still protecting from summer. We were letting some winter in. It was a high volume area. It also had a loft that was not used that often. It was one for their sons when they came home. So I had extra high volume. And so what I started to find was that we had probably a good circulation pattern. Also, there's a fair amount of radiation that takes place from the heat that stays up at these areas prior to the great change in temperature. There's also a convection current that starts to work usually down the glass face later in the evening. So when it changes, we added the element of rock storage with the idea that actually that wasn't really in there, but with the attitude that if you took the process, you could bring the heated air down. You could also store it and bring it back later. The cooling process, of course, would happen by just the chimney effect of allowing the heat out on a very hot day. So without consciously doing it, in many ways, I think we had designed a very energy efficient place. Again, on this job, when I say we, Claudio Boccato was the architect who followed through and through supervision and worked to some degree on design on it. I don't remember who else in the office did. I think we two were the only ones on this particular job. Again, here's the volume inside prior to the loft area. It's a very tight little site. This is looking down from the loft into the lower area. And then there are other areas that are additive rooms that also would be solar gaining rooms in a passive way. So then I'm showing this section. This was another house, the stone house, that was very effective and heat-wise. And what it did was what I was explaining before. There was enough overhang to cut out the summer, it let winter sun in. That, because of high volume, the heat stays up top, so there's still a comfort zone in the lower area. And there's a lot of heat that's gathered at the ceiling, and that radiates later in night. Convection does take place along the glass area, and there is an exhausting process when you have to get rid of the hot air. So this house, again, was somewhat effective. And this is a corner of it with a fair amount of glass again, a look at it in elevation. Another house that was effective heat-wise, was this house up in the hills again with a fair amount of south and east and southwest facing glass and a high volume. So with three houses faring very well that did the same thing, houses that should not have, according to energy codes and so forth, worked I used this premise later in many of the houses that I designed. So starting with this one, these are not in the order in which they were designed, but I put them in order in a way to just explain some of the processes. This is a site, again, over in the cooler part of town here. There's a creek running to the right. The amount of buildable areas was pretty much a straight piece of site. Sun was coming 45 degrees south to this area, so the solar collectors are tilted, and greenhouses were added to the side. I'll show you further in concept would be this. This is the sun location. These are greenhouse areas, and these are solar collectors. Now this client wanted fireplaces practically in every room, and this would, again, would be good from an energy standpoint as far as burning and so forth. I needed in the greenhouses mass, so in this case I used a water mass filled fireplace. In other words, I used a metal container with water in it and used that method of collecting my heat mass that would then generate into the house later. The yellow circle over there was another one in which we were collecting the heat from the solar collectors and storing it in that container and then bringing it back in afterwards. In isometric, you can get a better idea of how the house works. And then as an energy use, this explains what I just explained again, the sun coming into the fireplaces, methods of closing the greenhouse areas afterwards, and heat moving through. So again, it's a fully glass house. It's not much different than many of the things that I had done before. The north side this is again in model the same thing. We used a dark container for the areas that would collect in the water storage in the fireplace areas, and a yellow for the one that was working the other way. And all the north side was pretty much solid and closed. So it's opened up to the south and to the southwest and closed to the north. Another house which was on a linear scheme was one in which I used, quite often I'll use the circulation pattern for the solar collecting area. So in this case it's a galleria, solar collector along there, some internal greenhouse areas again for heat collection, coming into a storage tank situation here. So it's a combination for passive use. Solar collector along here, storage here, and a series of, in a sense, greenhouse areas. With, in this case, was using floor mass, which was tile in most of those areas. Further diagram showing various kinds of closure systems as well. Another house, in all these last few houses, the one before and this one, Manuel de la Iglesia worked with me and did many of the drawings and some of the models and for this presentation, for my presentation over in the gallery. This one was an interesting one from a standpoint of client need, and in all cases I always feel wrong when I present, because I forget about the fact that in each case naturally the client's needs, the site needs, the kinds of space perception, all of these things are key factors. Structure is still an important thing to me, and so are all of the other systems. So my method of design is always a composite of all of these things as well as I can do them. And I don't deal too much with just formal issues in one sense, in the sense that they're being used today. You can still say that certain diagrams, certain patterns are certainly formalistic in their ways and their geometries, but they don't deal so much with, I guess, elevation as they deal with planned section and systems. This one, the client wanted a house that when they were away could be used in one section, and when they were there, they could use the back section. So actually there's, in this one, 2 circulation patterns. One that takes you up through here for this part of the house that they were going to lease out. The other was just a system that would be for their back part of the house over here for their bedroom when they were there. The house, again, was on a site where south is coming from this direction. Because the site moves up the same as the curve, I followed that as it evolved and stepped up with that. And in this case, we thought about, didn't do it, and I don't know whether it made any sense anyway, but they were tracking kind of solar collectors. It seemed to us it would be interesting to have tracked them, particularly on this kind of a system. The collection then, we're also using this pool as a heat sink, collecting the hot in this area, which I'll explain in another diagram better, then using the combination of the structural system and mechanical system to generate the heat back into the house in a common system. So it looks like. And then this is a diagram of that system that I just expressed. Is that focused well enough? That looks a little off. But then again, this is just showing the working parts, the collecting parts, that coming into this place, heating water and holding this to this gathering sun, and then distributing back through the house, through the structural system and mechanical system combined. Now, in many of these cases, these, like in this one, which didn't go any further than design phase, much of this was not worked out beyond this. So this would be a concept for an idea that may or may not work totally. Usually, whether it be a structural concept you have, or a mechanical concept you have, or a solar attitude, or an energy attitude, usually the architect's role, in my mind, is usually to project ideas or attitudes that can be used, and the engineer or the consultant's role is to make those things work for you or tell you where you're wrong, have you go through the adjustments that take place. But if you don't project first, it's a rare engineer, although we have one sitting in here tonight, Saul Golden, who will give you something before you ask for it. Usually you have to project things first. And I think if architects don't do this, they can't expect their involvement with it. I feel at school, so few students today really want to project particularly energy ideas. If it's not called for specifically in the program, I don't think people go out of their way to do anything at all with any of these kinds of systems or these kinds of attitudes. And I think that's in a way too bad, because I think one should always be thinking about as many parts as they possibly can to the problem that has to be solved, and not just because it's satisfactory to solve it formally, do it formally, and deal with a few elevations and that's all, because that's acceptable, or you work with just certain formal tricks. I guess that gets me into my harangue, as Ricky calls it, but I do think that a student should call upon themselves to do more and to search out more when working on these kinds of issues. Another one that we're working on, that will be going into construction soon. The one prior to the one I just showed will also be in construction soon. We've been held up with a geological problem for quite a while. This one should start quite soon. This was interesting because if you can follow the contour lines, this hill took exactly this form. And normally in an area like this, what I decided to do was, it was a rocky, it's a rocky kind of a mountain slope. And when I saw that, it seemed to me that it would be nice to be able to use that for the mass, if I could close it with a greenhouse enclosure. Problem that you normally have in something like this is the city wants you to stay away from the bottom of the toe of the slope by X number of feet, or develop a retaining wall if you're pushing back tighter.
along with what I wanted to do, I also worked out a system that would work, that would allow me to cover the hill and get away with going all the way back to the top of my slope. So in a sense, I was able to gain, by just having thought about how I would deal with the energy issue, I was able to gain a much better kind of a situation as far as the way it would work with the slope, and not have to give up that back part of the site. There's a view site to the ocean that moves out from there. So again, the energy proposition here is collecting at this point using a galleria that's closed off, and then at night opening the doors and letting the heat penetrate from the closure here, then going back and closing the greenhouse later. Out here there's a series of trellises for east sun and south sun and so forth that will help protect from south sun. So that's that diagram. I don't know if this one reads, is that too light? I don't know. It's difficult, but again, this is the system later, the greenhouse system, the heat shown coming into the house, and that whole process. And then a solar collecting bank up at the very top of the hill, which goes right up to property line. This is that sloping bank. This is a series of setting. Actually, what I did is we're in this one, we're setting piling, and then we're spanning between with a little wall that creates the wall at the back part of the site rather than down at the bottom of the site. Another interesting problem we had that, again, didn't finally go ahead because of the city changing their restriction on the street width later, that made the site almost impossible to deal with. But it was one out it was in Beverly Glen area. And Beverly Glen years ago was cut up into very tight little lots, about 30 feet wide by varying from 90 to maybe 100 feet in depth, sometimes a little bit more. And when we got into this particular problem, we had to, our option obviously would have been to collect it and do housing with join walls and so forth. But in order to do that, one would have to go through a whole planning commission development and get an okay through that process. And we decided that we would just use the sites as they were and see what we could do with that. And of course, they were oriented in a whole series of different ways, and I didn't have the option that we normally had on many of the sites to make turns and twists that could get me to the south sun in a special way. So in this project, Bob Locke, who's here tonight, worked a great deal on this, and Manuel also. We decided to, one, just develop a series of very simple structural boxes that would fit on these particular sites and work in a vertical sense, and they would fill the site as shown in this model form. And then we devised a system where we would actually add components, and the components would be added in a fashion for sun control, for allowing sun insulation, sun protection, etc. So there's a series of screens, awnings, overhangs, glass-walled attachments, and so forth. And this way we could actually dress each unit as we had to make it work energy-wise. And it could, in some cases, it would be awnings. If we didn't have enough room on the side yard, we would use a tight-fitting system and so forth. So again, we didn't get a chance to really go through it, but I think the process was an interesting one, which was dealing with the idea of privacy, at the same time getting the best, most efficient energy usage that we could develop. And that project, we'll probably try to use that again at another point in time if we had a similar situation. Another project that is still in the works is a 3-unit condominium down in Venice. And again, this one was dealt with in a way where it was twisted in order to gain south sun. It also had to, it went with the alley in this face. And as it went up in section, what I decided to try to do on this one, since it was down at the beach, was to hang over the railings a water-filled, what would you call it? These plastic rafts that you use in the water, and just hang those for color, keep the water, and use it as a system of lighter weight mass. So again, this was a set of ideas that still haven't been tested, whether they'll work or won't work. And again, these are the forms that come out of that. In this one, the views were very tight, and so some of the pulling around the corners and in these areas was to get specific views out. This front corner had a view through, but it was on the other side of the speedway, and all the sites are rather specific. Again, most of my owners always want maximum glass. That's, I guess, what I'm known for, and so whatever project I get, nobody ever comes and says, give me a closed-up house. They're always looking for maximization of glass area. And different kind of a problem, which everybody, that also we can face or have to face periodically in energy response, are those that are really the non-house, or the ones that are subgrade or semi-subgrade, where you back your north side into the hill, quite often cover surfaces with a turf afterwards, and kind of minimize some of your openings. This was a project for Charmley, which is a county park, and this was a little it's been so long ago that we did it, I forget what we called it. It's a little building for people to come in and look at the various natural aspects of the park that are on display. Little nature building. Because we knew we were in a sensitive area with a great deal of concern by the people who live in the area, we tried to make it very much of a non-building. There's rock outcroppings that existed there, so actually our forms were somewhat addressed to those rock outcroppings, and it was a very just simple mass building out of concrete. It was dug in, as shown. The back wall was gaining heat. The ventilation system is shown through there, showing a system again of cover on the top and cover underneath, and a process that many people use today, solar collecting system in the north side out. Another building that's still in the process of construction that deals with mass and somewhat subgrade is the Bourget House. It was one that was designed quite early after the energy code problems, but has been slow in getting up. And this one, actually, Finn Kappe worked on it very much in getting the project up in the air and watching it through for about 1.5 years. It again, in concept, is a wall that runs through the house, east and west, that acts as the strong mass wall. The south side is a completely open glazed side, and the north side is primarily a closed portion of the house. This uses the plan systems are shown here. Rue Fort, who's also here, worked on these, and it reminds, and in the house to some degree. And in this case, the way it works, as I said, was that we, first of all, use this this wall that's running through here in the east-west, both in this drawing and in this drawing, for collecting heat and giving that back as a lag system. Top of that, I was in this one trying to deal with a system where the heat would rise to the top. I'd gain hot air at the very top. I'd pull that down into the rock storage and save that for later and address that and bring that back into the unit afterwards. There's some better descriptions of that. In isometric, you can get a sense of what happens on that south-facing wall. Here's that mass wall that I'm talking about behind, and heat coming through there. An additional skylight was put at the back side on the north side of the house that doesn't get as much sun, and in that case we were trying to collect on that back wall as well and pull through the house. But this one is heavy in mass and then uses a shading device. It's made out of this material, much as we use in Europe. I was going to say, explain it a little bit better here. One of those rolls up for closure or rolls down this way, and it's that system is an electrical system, and it allows control within. I'll show it to you on a section. So the idea here was, again, solar collecting at this point, allowing the sun to come in against the wall at this point. I show people here to show that what we're attempting to do is we would protect the system from this point, allowing the sun into here, so that at no time are you really into this whole hot area. I'm very concerned always about low spaces where where there's a lot of sun gain. So if you use a lot of glass, I always feel that you have to give a lot of volume so that you don't have the sun on top of your head. So anyway, that's the system, the shutter system up, the shutter system down, and this heat process that comes down in here and then recirculates later, and this later in the evening throws off its heat. So again, one of the problems that I'm having after all these years is that none of these jobs are really up to be tested, and the difficulty is that when you're dealing with things as I do empirically with general principles, but you don't know for sure if they're going to work until you've had a chance to see what happens. You don't really know whether what you're trying to do makes as much sense as you might think it should. Particularly when we looked at houses earlier where the concerns were not these concerns primarily, and we were getting fairly decent results. So the hope would be that these would be successful in terms of what one was trying to do with them. The house as it stands from the back side. And the total shot again. Again, still working with sites somewhat dug in. On the Bourget house that I showed you before, part of it is dug in, a lot of it is exposed. This is a site down in Santa Barbara that's a 45-degree sloping site. And in this case, again, I decided to use some of the existing hill, which is rocky, some water storage in this sense, make a greenhouse out of this bottom section, use the same kind of roll-up and roll-down devices that I was talking about before, once you collect in here to close this space off, a system of generating the hot air afterwards, a rollback awning process to protect this face or let the sun in, whichever we want to do. Everything in the purple color always in these drawings is the mass part, some rock storage at this point. So I'm showing the heat coming off the mass, showing this heat moving up through this portion of the house. Again, we're going to try to collect up at the top and pull that down into rock storage in this area. Solar collecting up at the top, exhausting up at the top, and fairly much the same principle as before. The house is somewhat designed as a truss on this face, which I'll show you later, with a concrete portion to sort of stabilize it at the back end. Again, a combination of a structural system, a volumetric system, and a heating energy process. It's on a south-facing slope. So this again shows you the greenhouse, the house as it exists up at the plan above, the mass points that I was showing earlier, and also the way it addresses the site, which is I have to come in from the top side, swing around through this to get to the garage area. So I spun it off to get in from that point. I still wanted to face south on my major facing view side and energy side, so the house takes its moves that way. Again, I prefer these kinds of turns and moves when they're meaningful, rather than just, again, as an attitude of change for change's sake. Not that doesn't work quite often the other way very well and gives you those forms. I just, for some reason, I usually need a reason to make my moves. I enjoy doing it that way more. It seems more meaningful to me through that process. So the sketch of the house. This house, the owner's going to build themselves starting this summer, so it was designed quite a while ago, but it's just going to get into construction. They're going to have he's a retired junior college teacher, and I guess he's going to want to spend the rest of his life building a house. But they're wonderful people, wonderful clients. Most of my clients, I feel, are wonderful people. They're very, they're great. On this house, again, the north side and the northwest side are fairly much closed, and the south side is the open side. What I was saying, the mass, this part is the mass holding the house, and then that truss playing off of that form. Also kept this one below the top of the hill. I had designed a house for another friend of theirs nearby, and we put it on the crest, and the winds I didn't realize how windy the area was, and they had a fair amount of problems with the wind coming from the canyon on that side. I assumed, because we were facing to the ocean, that the winds would be gusting up from below, but instead they actually gust from behind. And so some of the considerations here that I'm still a little concerned about in talking with the engineer is the kind of negative pressure that'll be built up on the glass face because of the wind coming up over the top and developing that pressure. Their feeling on it, however, is that when you're designing for your positive wind pressure, your negative won't be any worse, so that it should work okay. And if one wants to study it any further than that, it'll probably cost more than the house to study it. So architects, again, have to wing it quite often, as you all know, when we put ourselves out on some of these things that we're not so sure they're always going to be working, but we give it a try anyway. Then just in terms of a larger scale project, and this one drops back to early 70s, but it was sort of interesting to me as I've looked through some of the things we've done over the years. This was a new town during the days when new towns were very much in, and people were attempting to design new places for larger numbers of people. This one was actually a small one for about 10,000 people, and it was actually connected to a company. It was somewhat of a company town, a research city, and there's some research area that goes off beyond this. But what was interesting to me in the design was that on the downs, we actually had chosen all the south downslopes, and most of these back areas are all, again, dug in with the car parking really behind and the apartments out forward, or the housing out forward. And the circulation spaces are these units right that come down through it perpendicular. And the interesting thing to me was that in a unit of this size, in order to make it self-sufficient, probably the same kind of systems that I was using on smaller houses now, of using circulation, which was south-facing, for photovoltaics or for solar panels, would probably collect most of the energy. There's water down in here. I guess we could do a certain amount of storing using it as well. We were damming at that time, more for visual purposes, but it could have other advantages. So in a sense, I think if one is dealing with larger scale and uses some of the same kinds of principles, they'll work for you there just as well. So this just shows it again a little closer and some of the stuff that would possibly have worked quite well. And the section through was one in which, again, we were dug in with the car parking behind, buffering it, the south-facing side with sun protection, and it probably would have been a reasonably decent system. Now move on with, again, another kind of a group that's somewhat different from the others. This one is a project that I worked on with Dean Noda primarily in the office. This job was on a very, very rough site. There's actually a valley that breaks through the site through here. The point right up at the top is the only place where it addresses the street, and that's the car parking area. There's a bridging over this area. The master bedroom suite is down here, bridged away from the living and kitchen and dining portion up at the top. That's the plan arrangement. This shows some of the energy considerations and why some of the twists and the turns. I start out addressing the street, and that's the parking area. Then, in this case, again, we used the knuckle system of the rounds, and took a turn on each of these stairwells in order to get the south-facing view. The view's out this way, and also the sun to the solar panels. So this one takes a twist. Then we take another turn to move across the site over the valley, and then come into another knoll on this side, which again, we take the turn to the south side for this unit. So the whole system moves through in this kind of a fashion. Also, there's so many stairs to walk up in this place that they don't have to jog very far. They just run around the house all day. But it is a very, it's a very involved place to come from your master bedroom up to get the morning paper. But I always feel that's a rather nice experience, and feel that people should, since most people today who are fairly affluent spend so much time worrying about their health, probably the house can be a health unit just by making them move in there instead of coming home and laying down after they've run around for most of the day. Anyway, the process here is a heat trapping system that works on, in this case, the west face that gets the later afternoon sun. This one was to be closed off from both sides. As you see here, I think I have another shot of this, but I forget. It's a roll-down system that protects it when you want it protected on the outside face to keep the heat from going out, and on the inside face from coming into the house when you don't want it. And so later in the evening when it gets cool, you open this side up, let the heat in, and you roll it down on the outside. The house as it was designed was this way. It actually wasn't built this way, but in concept, I still like to show it this way better. It was meant to be lighter and more of a bridge house in steel and with really metal skins that could have been applied in a much simpler fashion. The house, as many of you know, was built in wood, and it was much heavier and not nearly as in my opinion, it's as interesting in terms of the perception of movement through it and some of the other aspects of it. And of course, it was put together really well by Claudio Boccato, who supervised it, and along with Dean, who had supervised it earlier, and worked it over very, very well. But still, I always enjoyed the earlier concept, which was a lighter one in which we were also expressing our solar collectors and in a way that the ceiling would be a combination of the collector and the north light. And also a little more openness in the bridging wing that was to be an art gallery. So I always kind of liked it better in this level. These were the structural elements, not just glass surround. We didn't show the internal parts that were holding it. And that they later were changed to wood as well. But it's still, I found the process of the house an interesting one. And I think it's, spatially it's interesting. I just wish it could have felt lighter to the hill than it does. I feel it's heavier now. And there's that diagram again of the roll-down system, and then the heat lock system. Another house that many of you know, this is the Friedman House in Santa Monica, and this house is built, again, had an attitude originally of wanting to work with a center court and a solar system, collecting system up above, which I'll show you in other diagrams. And then, of course, this steel exposed system came later. This house, Tom Foe worked on with me, and Rex Luttery supervised it most of the way, and I ended supervising the end of it. Originally the concept was a combination of collector in this part over the garden with intervening glass areas that would drop down into this area of the garden, and the purple is showing some mass collecting. In the initial concept that I had, I thought I would probably close this as a inner garden and then allow it to open in the later day and let the heat in through the process that's shown there. So it's really just an internal courthouse. What happened later, originally when I had thought about it, of course we were getting south sun here, so again it's one of these 45-degree turns for the sun. My thought at the time we had a stairwell mass here was that I would shade a certain amount of south sun. Later, as we got into with the engineer on this and so forth, he felt we didn't have enough. We were shading too much during the wintertime, and we probably wouldn't, our collectors wouldn't be as effective as they should be. And so we dropped the collector at this point, which I wasn't too thrilled about, but we went along with. We moved the collector just up onto the roof in a normal process and opened this up as a skylight totally. Again, conceptually, I still personally like, this move first. Again, with this 45 turn, the bridging and the movement and the circulation through this house also took the same 45 turn with the room above. Again, this was something that I normally don't do, but and probably would have run around this thing a lot more. But then as I started to look at it, the amount of wasted space just in terms of getting from that we'd have to cut out of these rooms in order to use a normal galleria made a lot more sense to turn the 45. And again, this was interesting to me later because as I said, I don't do that much internally, in that one move I feel set the house in pretty good motion. And I think today so often people do so many moves, and I don't think it's not necessary to make that many. And here I found that one did it really quite well. Again, that last shot was showing the internal garden, and we used in the planting here avocado trees and citrus trees to kind of give it a special internal quality rather than normal planting that people use. You can see the way the skylight is now. But this house has worked pretty well. Of course, it works from solar, but at the same time, the skylight does pick up pretty good heat. It has good volume, and the house heats up pretty well in the daytime without a lot of added heating. I've explained, I think, before to a lot of you how this whole steel frame came about. Actually, it was originally designed to be covered over in plaster, and when I came back from my sabbatical, just the steel was up. And this is one of the things I think Rob was talking about last week. I liked it so much just the way it looked, and I think it cost they had about $25,000 into it already. And I called the owner and I said, how would you like to leave the steel open? And we'll just, because it was a rigid frame that to me was very funny, because it was a disjointed or a broken frame in the way it looked, and yet it was acting as a rigid element. And I asked the owner if they would be willing to leave it open, and they liked it very much, and so we then just let the rest of the house go around the frame, and reworked a few things, some of the railings and a few other elements on it that Dean Noda worked on too quite a bit. So anyway, this is the way it finally came out, and I enjoyed it really more, even though there was a certain amount of crudeness that took place in some of the joints, and also leaving it just the way the engineer had designed it rather than the way I as an architect might deal with a lot of these issues and be much more fussy about it. So again, I've said this before here, but I think allowing the process to take place is important, and I think the idea, and I think some of the things that some of the younger people are doing today are interesting because the process seems to allow the people to be much more a part of it, and it's not quite as precious as I think some of us have been in previous years. The balance of that is still something I think all of us have to really concern ourselves with as we deal with these issues. But I found the process an interesting one, and particularly to find strange things like pieces of rigid frame as railings rather than, and normally they'd be in the floor. And just things that happen are happenings rather than pre-designed. Have a couple more and then I'm all through. I promise not to go so long so we can have more time over in the gallery. But this project was a gymnasium for Loyola University, worked on with Clelio Boccato and I'm leaving somebody out, Dave Van Hoy. And this was one of the most interesting group projects I think I've ever worked on in my 35 years, or 30 years I should say, in architecture, in that the decisions were made, in my mind, always in a rather rational way, which I still enjoy. We went through the process of studying all the various structural systems we could use over the kind of span we had. We looked at it, in many ways for energy attitudes. We had an existing gym to interrelate with, and what the best kind of connection and how to use that connection and what it should be. It was a gymnasium in which we opened up the whole end, and I'll go into that in a few minutes explaining some of the energy stuff. Didn't feel like we were forcing every issue. We tried to make the best decision we can make. The element over on this side actually is both a weighting system for the support system for the cable roof, and at the same time it takes the winds from the ocean and takes them through the building in order to cool it, along with the wall on this end that opens up for cooling purposes. We didn't want to air condition this gymnasium, and so therefore we were trying to use the air scoop process. We looked at we do this on a lot of jobs, but this one, because it was larger scale, we had a whole series of considerations that we drew up at that time. Our office was never known for overdrawing things, so sometimes presentations are a little light when it comes to the kind of material that one wants to give. Anyway, this is showing the use of the prevailing wind for cooling. We're talking about storing stormwater for irrigation. We're looking at natural lighting on a couple of spots, the solar collection process, the hot water storage, etc. So those were some of the considerations. In section, this is again the scoop that works and how the space ventilates and cools and heats and so forth. And again, the close-up of the air scoop and the tie-down shot through it, showing how it would work for other than basketball games, where it would open up totally for auditorium. A truss system here, just a full span, so we could open up that whole full side. So, and then a solar panel system on the juncture the other way. And then, instead of dealing with the old gymnasium and trying to repeat it, we actually took what we felt was a nicer move, where we were counter-moving to the original bowstring truss system, I think, or lamella roof system, I forget which it was. So we were actually in context working opposite from the system that was already there. I think this is the last job I'm going to show. This is Santa Monica Bus Station Administration Building, Santa Monica Bus Administration Building. Again, worked on with Dean Noda and Rex Lotery. Dean actually being responsible for carrying the project through the last stages, and I think it's bidding now, and hopefully it'll come in and it'll work. But this again is orientation-wise, this is the site. Building again placed on normal access to the bus storage area on the side. The truss system working 45 degrees to that. In Santa Monica, the grid is 45 degrees off the sun axis. So throughout that whole area, and usually through Venice, and most of these areas, there's always that 45-degree turn that one should deal with or can deal with, which I find really an asset. And I guess what I'm really saying is quite often by looking at energy considerations, in my mind, things happen that are, I think, quite often more interesting and better than they would come through the other process. So again, the concept in terms of energy and heating and cooling and so forth, and again, when you're into this kind of a building, cooling is more important than heating because of the heat load from the lighting and so forth. Also, the heat you need is usually just in the morning a little bit, and then you want to develop some cool air. So I was using a scoop that came out of the side of the building, went into the heating area and into a plenum that is shown in purple, where work all around the building. The water system would work separately and store and heat through that process. On the south side, you'll see the kind of system, I'll show you in section what we used. On the west side, we tried to change, one of the concepts as we were working on this was to allow it to really each of its exposures. And really we would be doing probably more changes than we did on the east face or on the west face and on the south and north face. Certain exposures didn't make that much difference. East and south kept somewhat the same. West, we recessed the glass areas and the office areas below and used a fin for protection of those and a system. This whole area that's shown with glass is a bridging element that is used for daylighting purposes, which I'll show you in section, and also the facing side. The attitude there also was to collect later afternoon sun. This is the only part of the building that's used in the evening. And what we thought we'd do is collect some afternoon heat there, actually put that into a plenum unit and also feed that in later at night. And that was the concept. In section then, these areas that are shown in purple are those plenum areas that run all around the whole building. The daylighting process is used where you used a series of horizontal reflectors here and there. Viewing, they were set up in a way that when you're standing through that series, when you're sitting down, you're viewing through this series. The reflection process works like so that you're getting your light, back as far as possible into the building. Glazed this area, which was back in the double quarter area. We used the single quarter upstairs to in. So this building, I think, is an interesting one in contrast to some of the ones that were shown by the state architects, in that they usually were courtyard buildings. This conventional kind of a building, and using other devices to bring in daylighting other than courts. A court is 2 stories, so it makes it easier than higher. But actually, you could probably still pull kinds of daylighting processes down through if you deal with that set of issues. Shown here, solar collector up above, and about it on the concept of the building. Looking at it from the west side, then the systems, the baffle process, the buses move out from. This is, and the east side is back to the system, and the north side is fairly much glazed. To me, one of the sad building was just the fact that, about the aspects, we were many more outdoor courts and terraces and things like that. And administration people seem to be, the building would feel too good, I guess, for their so they tended to not want the, that was, you know, up under here we had a lot of open areas. Instead, they wanted more parking under there and so forth. But it took its form, and it's pretty much, or totally, really, from and daylighting. And again, that's, and of course, some of the aspects that are more kinds of rounding of corners, the kind of skinning, of course, trying to give it somewhat of a bus image without, you know, being a bus. Thank you very much. Okay, why don't we just go over and if you have any questions, I'll answer them there. One of the good, really good flexible rooms, and it's worked real well for us through the years. Bob, I think this morning articulated, as I started to say, the position of, I think, the educator and the practitioner quite well. I, like he, I've always sort of thought of myself really as a practitioner first and educator second. I practiced 35 years. I've been in education maybe 18 years. And the reason, what I'd like to share with you more than anything else is my experiences, because I think they're rather unique in the way that they occurred. As a young practitioner with a small office, I was always interested in what was happening at USC. I was a graduate of Cal, and I would keep sort of track of what was going on over there, and I always felt that my little studio was a place to teach students from SC a little more. And it happened that the philosophy and the attitude at that time were quite similar to what I was doing in my office, so of course it was very simple. And it was my form of education to the student at that time. I had a couple of years of teaching off and on, like many practitioners sometimes do at USC, during the 60s when Sam Hurst was dean at SC. And there was quite, at that time, the same kind of discussion we had this morning was really taking place in LA. It was the 60s when methodology and sort of a new architectural language was taking place, and those of us who graduated after World War II or through the 50s were wondering what the hell these kids were talking about. You know, it seemed rather abstract. At that time, the question really was, why can't they draw? Or why can't they do other things than just think and ask questions? Because I think most of us, through our period of time, really stressed
the other area. I think we drew more, we really designed more by the seat of our pants, and really didn't ask as many questions back in the early 50s, although I think we worked from the heart, and maybe that in many ways that's better than working from the head, or the combination is the reality. At any rate, at that time I was observing SC, and I felt that Sam had a good program together, except that he really was doing what I thought was really quite incorrect. He was, the practitioners who were teaching there were being let out. And he believed that the school should be all academia. In other words, if you're going to teach, you're going to teach, and you don't mix the two processes. That never seemed to make a lot of sense to me. It also seemed to be structured in a way that it didn't allow the student to do the variety of things, the kinds of questions you asked this morning. I think the questions that were all along those little cutout dolls were right on there. They cover all the questions that any of us, I'm sure, have ever had about why isn't education what it should be. So in the late 60s, I was offered this position at Cal Poly, which was at that time a landscape and urban planning school, to start the third leg. And it was something that I felt, gee, you know, this is really terrific. Even though I have to travel 50 miles out there and 50 miles back because I lived on this part of the city, it seemed like a great opportunity to really put myself in a position to try to answer the questions that I always had about education. The same questions all of you had this morning. And so what I can best do with you is just share these kinds of thoughts. So I went out there, not so much, as Paul said, to turn a whole different notion of a school. What we wanted to do is have an energetic school, a school that within a state system could use, could operate within that system, but hopefully generate what we thought could be one of the better schools in the country. And so I had a young staff who we brought in young people, and I tried to bring in practitioners. And my experience early was that practitioners usually lasted about one quarter, one semester, whatever, it was quarters out there, and maybe two, and then they get busy and they'd go back to their practice. So generally speaking, they never wanted to do the same thing that, say, young people coming out who were sort of trying to start their own practice or who had not really established themselves would do, and that would dedicate themselves to both, to becoming practitioners and to becoming educators. But still, I didn't give up on that. We kept trying to incorporate them in a variety of ways. Because it was an interdisciplinary school in terms of the three design fields, we tried to integrate that and develop an interdisciplinary environmental design school out there. To do that, I felt that architecture had to be kept as small as the other two departments. They were both in 150 to 200, and I said to the president and the vice, well, really I worked with the vice president more than the president, that I didn't want architecture to be any larger than the others, because if we're larger, we need more faculty, we need more money, we need a bigger part of the pie, and immediately you don't have equality of the process. Because architecture was and is in a university setting or even any school setting a good draw compared to planning and landscape, they could build a much larger school. So part of the conflict that started early was they wanted to keep pumping our numbers up, and I was trying to hold them even and trying to develop this other process. And in those days, again, in the late 60s, there was, as you all recall, or maybe many of you recall, the idea of interdiscipline and the idea of really the non-star system was very prevalent. We were trying to build architecture into a different place, I think, than it had been before, and probably wrong, you know, but I mean that was because it doesn't seem to be able to, you can't usually fight what has historically been the process. At least that's what I've learned, and that'll sort of be my conclusion here. But so anyway, after 3.5 years of what we thought was a good program, what really took place out there was a dean-chair power play, and that created on campus kind of a cause célèbre. The students backed our young faculty and me, and one day after about 2 months of battling back and forth and God knows what on the campus, one of the students, and I think at the same time a lot of us were thinking the same, let's start our own school. Why just say okay and give in to the usual system that takes place. Let's see if we can really do it. So we decided to come to the west side where most of the people were living anyhow, and we looked around for some buildings, and we found this place, and it seemed like it would do the job. At that time it was sprinklered and it could operate as a school, and we opened up in '72 with really no money. We just started from scratch, and at that point in time my feeling was that I didn't want to rely on grants, and I didn't want to rely on any outside help, and that if we couldn't make it go on tuition only, it wasn't going to fly. And that's exactly what we ended up doing. We had 70 students, we had 7 instructors, and we put together a program that is difficult to do today, but in those days, because of the attitude of students and so forth, it became something that could work, and it did work. And it grew, and we were in reasonable financial situation early. And what the difference was, though, when we came here was great, and I'll talk to you a little bit about that. Leaving the normal university system, our thought was, how should we establish our program here? Should it be a 4-2 program? Should it be structured like we had it at the university? Should it be wide open? Those were the days of alternative education, and how do you go about something like this? We had a building that looked kind of open and free. Could we develop a free program? Could students become more self-actualized? Would there be a process other than the typical that would make students think better, be stronger, more self-motivated than the typical systems that were always put in place? So we had in the background kind of a structure, but we decided to open it up in a real broad, wide open way, and tried to have the students who at that time were expressing independence and in the old system, and who wanted to really do their own thing. Let's see what happens if we allow that. And so I've had, fortunately, an experience that's really unique. The ability to start 2 schools really from scratch, which I don't think anybody else has ever had that opportunity. I'm not sure I deserve that opportunity, but I guess it happened sort of circumstantially, and also because I'm like the kid this morning who's looking for the pony. That's the way I think about things. I'm naive enough to believe in something that can be, whether it's right or it's wrong. And I had faculty and those who started with me who believed the same. And so we started that way, real wide open, we used to have seminars just sort of floating through here. People would come in and visit us. It was really quite great for a few, 2, 3, 4 weeks. The place was, the place was empty, and we said, okay, make your own place in here. Here's your chance. You're in an empty building. How would you set up your own environment? And after about 5, 6 weeks, the students were really getting frustrated with the whole process, because in reality, the hardest thing in the world to do is be have that independence, be able to do whatever you feel like doing. And so they said after about 5, 6 weeks, can't we structure this thing a little bit more? I mean, we like choice, but let's have a little more direction. And do you guys really believe that we learn together? Teach us. Our process was really that, or at least what I had in my mind was the idea that in real life we learn not during school, and then we learn afterwards by finding out what we have to know, and then we go and we seek it out. And I think most of us really continue with that process within ourselves once we leave school. But while in school, there's this tendency to want to be taught or given information. And that's probably correct, But I had to see it to believe it, and I had to have the opportunity to see it to believe it. And over time, that's exactly what occurred. And it was interesting to see it evolve over the years, and it didn't take too long to be pretty much back into a normal structure. So this morning when I was hearing Bob Harris really talk about his structure out there, well, we have a 5-year Bachelor of Architecture, and if I gave you a diagram, it would look exactly like SC's diagram. Not that we followed SC, and in a sense that both of us, in a way, arrived at the same time, because after Sam left, I think Jerry Weisbach started that program in '72 about the same time I did. He and I were somewhat similar in thinking, and as it evolves, I think we ended up with a structure that is reasonably normal in the 5-year Bachelor of Architecture, and that's that the first 2 years are disciplined and structured, and you let it out as you go. And we also have that same 3rd year period where we feel that that's the end of our core, then we have some options, and then 5th year we bring them back again. So our programs, our places look different. Our programs in the 5-year Bachelor of Architecture are very similar. Our master's program, which we also is very similar to UCLA's master's program. We use a 3.5 year program with people who have other degrees. And so we have 2 testing grounds that are very similar to the other 2 in the city, except again, I guess our place is different and our actors are different. And the actors are still what makes the game go. I mean, the people who teach design, no matter what structure you set down, it will evolve in its own fashion by the people, unless you're an autocratic about it and so forth. But if you believe in sort of a free society and an open society, and after all, that's what we all live in, I think we should demonstrate that in school. That's the way it evolves over time, and that's what's happened here. As far as, we also have the 4-2. I mean, we have all the programs. You name it, we have it almost. We have a 4 because we figure that there are many students who may want to finish at 4 and go on to do their master's work in other parts of the country, and so we have that program. We take other students in with degrees who do 2-year, 1-year masters. So I think we have most of the programs. Our 2 accredited programs are our Bachelor of Architecture and the masters coming from other disciplines. At any rate, that's been the experience over time, and I think, you know, we've tried to ask most of the questions I think that were asked this morning. And if I could, just for fun, because we're somewhat different than other universities, that we can't tie into their other departments. When I first started at Cal Poly, I thought I had the great idea 18 years ago that I would have 4 or 5 different ways to go. I, like you, who asked the question this morning, is everybody a designer? I said, no, they're not. So why don't we train people in architectural administration? Why don't we why don't they have a thrust in contract documents? Why don't we have a thrust in construction administration? They had engineering departments, they had construction departments out there at Cal Poly, like they did at San Luis Obispo. They had business schools, so there I thought we could really do some of that. But what I found, and again, I believe I believe in what really happens is what the reality is. And so therefore we tried all those programs. All the students wanted to be in design, period. I mean, it didn't matter what we would do, that's where they wanted to be. At the end of 3rd year, I remember one year, we had about 6 students flunking. We said, hey, if we got a program for you, you know, you can, we have one that really emphasizes construction documents. We've got that all in place and so forth, and you can be in that program, and they kind of, with long faces, said, okay. And as soon as they could sneak out of that again, they were back in the design phase. So I think the reality is, and I think you all probably recognize this, is that all of us are different as individuals, and we'll probably find our place in the real world later in what feels right to us, where we fit better. In school, the desire for 5, 6 years is to expand our heads as much as possible, learn to ask the questions about design. Yes, design is the key area, even though we teach 35 other seminars and lectures every semester. And I'll read some of those to you so you can see what we try to cover. But the reality is, I don't think you change that. And the questions are right this morning. When you're a practitioner later, it all seems so stupid why there aren't some people who learn other areas. Why don't they learn to learn how to market, you know? Why don't they learn the business end of it? Why don't they, you know, we've tried, really, we've tried all that. Somebody else might do it another way and do it 100% better, but we've tried it at every level. I've asked myself, and I think we've through the period of time, we've asked every one of those questions. Can we not make a better balance between the design portion of teaching architecture and the practical aspect? And again, we teach our professional practice. We have the intern program. We've had it in place for 6 years. We don't have UIG because there are some questions I've always had about UIG. In principle, I think it's terrific. I think it should do things that architects aren't doing, and I think what happens, I mean, I've been shortlisted with Barton Meyer and Charles Moore and always connected to UIG, and that's not too happy, I don't think. I mean, that's the only problem with it. I think as long as they do single-room occupancies, and just as we would do if we moved from here to downtown, I think there are areas that are important. I think they can offer the profession, as they were supposed to, a research leg. I think all of that was really well thought of when Harvey Perloff thought about it, and I think Rex, my ex-partner, is trying to get that back that way to some degree. But it was also meant to be for the young practitioners to have this sort of as an office base. But what it ended up doing is really not quite doing that. It became a competitive leg, and that's my only criticism of it. Other than that, I think it's a fantastic program. I think it gives the students an opportunity to learn and an opportunity to work in a good way. And eventually, we'll probably do it in a slightly different way, particularly if we move from here to downtown, as I alluded to before. But anyway, so I don't feel I know all the answers. We've tried things, and we'll keep on trying. I believe in running anything up the flagpole. If it flies, it's going to be ongoing, and if it doesn't, there's a reason why. It's not the time. The students aren't ready to take it. The students aren't ready to be involved with it. The professors around aren't going to be involved, and it's hard. But let me, in other words, this would be a typical fall semester. We have Pro Practice 1, we have drawing for the graduates, we have Structures 2, we have Structures 3, we have Computers and Architecture, we have Landscape Architecture, we have Architectural Communication 1, we have Lighting, we have Italian for Architects because we have a school in southern Switzerland. We have Architecture Planning in the Social Sciences, we have Space, Time, and Architecture for those who still believe in it. We have theory classes like Between the Past and the Future. We have the History of Japanese Architecture. We have Building Design and Structural Concepts, History to 1850 for the graduates. We have Architecture and Archaeology. We have the 20th Century Materials and Building Systems, Advanced Communications, Model Making, Urban Planning and Development, Structures 1, Structures 4, Advanced Communication Drawing, Computer Applications, Form and Meaning, Perspective and Delineation, Video Architecture, Materials of Construction, Meaning and Landscape, Project and Office Management, Economics for Architects and Planners, History to 1850, Part 1, Mechanical Systems, Architectural Communication 2, Structures 1, Modern Architectural History, Part 2, and Twilight of the Idols. Not in any, I just read them as they happen to fall in our curriculum, not as they're required or anything else. But I mean, that tries to cover every goddamn thing that's out there, I think. You know, what we don't cover there, we try to do it in the next semester when we go to Pro Practice 2 and so forth. Now, why the students aren't as a whole excellent is because people as a whole aren't excellent. We vary. There's some very brilliant people. We have those. There are some people who aren't so brilliant, and there are a lot of us sort of in the middle. And I don't care what system you use, eventually it sort of filters down, I think, that same way. And I know a lot of you have, you might say, well, how in the hell can a person be disciplined in this undisciplined environment? How are they going to fit into my office? But they do. And I can't say that there's a difference between a 5-year Bachelor of Architecture and a 3.5-year graduate program. They're different people coming in, they're different people coming out. Some of them, the graduates, will be the kind of people you think are fantastic, and some of you wouldn't have them in your office. And a lot of you will think the undergrads are terrific, and other offices won't want those people. So I think you know, if anything, I mean, one nice part about you guys being here is I think I think we've tried a lot of things, and the kinds of questions that have been asked today are terrific questions, and they'll be going on forever, and I don't know how you solve that. As far as the solutions, I think Bob Harris hit a lot of them today. Like SC, it was interesting when you came here. I thought, well, there's a question about how do you get the educators and practitioners together. On our design staff, or our studio staff, which numbers 33, we have 20 AIA members. We have 5 others who are licensed architects who are not AIA members because probably they don't want to put out the money this year, or you know, they don't have offices that warrant it yet. And we have 8 people that are either in other allied fields or aren't licensed yet, who are young practitioners. So from that standpoint, we really are, you know, fairly much aligned with AIA and with the practice of architecture. And at the same time, we have young practitioners and some older practitioners who have diverse points of view. And they're part of the I mean, our school probably has the largest number of avant-gardists of LA around. Probably because we have a free system here, and it allows these young people to grow, to experiment, to explore, disturb you and me, who are, you know, maybe of a different generation. But it just, you know, that's part of the process, and I think it's okay. It'll all filter out. You know that. You've watched the cycles. I've watched the cycles. They change, and they go on, and what's correct today is wrong tomorrow, and the rules you learned when we went to school are opposite today, and the ones that are today will be opposite tomorrow. And I don't know what you do about that, and other than just try your best and do your best. So in a nutshell, that's been my experience. It's been, you know, 18 years of looking at it, trying it, exploring with it, enjoying it. And I think that's all I can share with you. If you didn't have a chance to ask questions, I know at SC, if there are any other questions you want to ask, or if you want to just go have a good time drinking wine, it's fine. Yeah.
My wife wants to know if everybody graduates, do you flunk anyone out?
Well, we don't. The flunking process, you know, in architecture schools, you almost don't have to flunk people. There's an attrition that takes place almost naturally. There are people who fail, but I didn't believe even in the failing process when we first started. I believe that everybody should have a chance, that the chance to succeed or fail should be left up to another point in your life, and that there shouldn't be people who constantly say, you know, you're no good at the end of year 1, or you're no good at the end of year 2. But, you know, the process in the studios, that happens, obviously. They get credit heavy, people start to feel insecure, they probably don't feel good about themselves. They're told that they're not doing the work they should do, and they probably move out of it. Along with that question, another thing that I had an opportunity to do, because it was talked about this morning, is, you know, you said, select the brightest, most intelligent, best, wonderful, God knows what student. And again, I thought when I started here, geez, what a great opportunity. We're going to interview everybody, first of all, and at the end of 5 years, I'll know everything there is to know about the way you allow people into architectural programs, because we had an open system, and therefore we allowed everybody in. And you could sort of get a test. Those with the higher grade point averages, those who were Phi Beta Kappa who are now returning to architecture, those who were high school dropouts. You had all kinds of people to look at. And the reality of that was interesting. You know, you had your exceptions. You had your high school dropout who became excellent. They learned to think in architecture. They learned to expand their heads. They became fairly well educated, even in our process, which doesn't relate to a university. There were Phi Beta Kappas who were intelligent wherever they were before, but didn't really find a fit in architecture for them, and they would drop out. Generally speaking, when I got all through at that, probably the process that has historically been used, which was the GPA and some interview, was probably still the best way to judge. And so today we do that. We try to select out. But I don't think through the selection process that we necessarily get a better student than we had out of that non-selecting process, because the early students had a certain, here I am in this place and I'm going to make it, God damn it. And that's probably worth more than a lot of other things sometimes. So it's really a hard thing to do. I recognize that you'd like everybody to be a good, a strong thinker, brilliant, be able to, grow more in your firms and be better people in the profession, have social consciousness. That was another thing that was very important to me early, but you can only, lead the horse to water.
You're accredited. Where do you pick up your humanities and your science?
Didn't you hear our list? No. The graduates, of course, have their degrees ahead of time. The undergrads generally have 60 units of work before they come in, although some come directly from high school. Those who come from high school, we originally had a core set of about 4 types of seminars, lectures that we tried to bring them up to par with. Over time, we feel that those who stay in the program, and by the time they go through the concerns I think that architects truly have and that the faculty have, and the kinds of courses that you have in theory and humanities and behavioral sciences that we deal with specifically in architecture, that they get a fairly good, I think, a good background. My thought always was that after they had this beginning, that they would go on to take courses at university because they cared about taking those courses at the university. That's another one of those, search for the pony types. But that was the type that doesn't happen very often. I guess, what happens, if I may use myself as an example, I think those of us, when you look back, you wish that you had taken more time in all the social sciences. You wish that you had spent more time in literature, and some of us have. You wish that you had read everything there was in philosophy. You wish that, on and on and on. And in a sense, you would like to put that back on the student coming in, or you wish you knew everything there was to know about business, or how do I make money, or how do I turn this, and what's the way to market. I mean, a lot of that is that kind of thinking, and many of us can do various parts of those. But I wish the hell I knew how to market. I can't teach it, and the worst person, the worst young person, the nicest young person, but one of the least talented young people who ever worked for me in my office today has one of the most successful offices in terms of dollar income, because he was bright enough to know how to hire people to market and how to market. They do a decent level of work. They're a respectable firm. It's fine. But if I were to say, of all the people that ever came through my office, he would not have been the one that I would have thought might have done that. It's like, who's most likely to succeed? Well, they don't always. So those are hard things. But back to your question, we do the best job we can. We try to do it through advising and counseling. And generally speaking, I think the people are bright and intelligent coming out. Yes. John, I'm sorry.
With all of the diversity that you've outlined to us, the different characteristics of the students, what do you believe our position as an institute should be for education and influence?
Well, as I said, I thought Bob really answered that in many, many good ways. And so I had a hard time answering that question directly, other than the ones he asked. I think to keep asking questions, the same questions over and over, are good. how do we get a closer relationship between the two? I think the kinds of things that the seminar programs that go on and the tapes that are made are useful and helpful that can be made. Certainly, you know, his recommendation for monetary assistance, well, I don't presume to ask that other than if you were able to get it from outside, because generally architects historically, and I've learned this through experience, are not, you can't count on that, on them for developing, you know, grant programs to help the process. But I don't know. I guess it's just keeping the dialogue going every few years to go through this question and answer, you know, that we go through. Hoping, I think in many communities, again, you can't use the West Coast and the East Coast as the same examples as you can for parts of the other parts of the country. In many cities, if you're not in the city, it's much more difficult for the architects to interact. That's why this program has been now used by other programs. I mean, there is a proliferation of independent programs going on in the country, because many cities want programs in their in their communities so that architects can relate closer. Portland is one. I see them in many places, and I think that's part of it. The other is, I think you know, the education that you provide in your offices is real important, and I think the idea to spend time and dedicate time for that is important. That you don't feel that well, I have to teach this guy, it's going to cost me money, I don't want to do it. You have to assume that responsibility. The state of California has not assumed the responsibility for IDP yet. I think that's terrible. I think IDP is a good program. I think architects should fill out the damn forms, and I think they should take the time to do what they have to do to help the student after they graduate. We can only get 100, I mean, in a professional practice course, which is, you know, 4 hours a week, 15 weeks, that's 60 hours, double that outside, 120 hours. In 120 hours, you know, what do you produce in your office? They can learn in 6 weeks in an office much more than we can teach them, other than to introduce them to the process. Most people work while they're here. Most people have reasonable skills. Some do, some don't, but most do. And so they're able to, most of our graduates are employed. But then it's up to you to take that next step. I agreed, you know, I filled out the form that you all filled out this morning, and just like everybody else, we're all in agreement. The schools have their responsibility, and the profession has that ongoing education responsibility. And you can only expect that much. And if we really think back and are honest with ourselves, what did you know and how good were you when you graduated from university? I mean, I know what I knew and where I was in those days, and I had to pick it up fast in the first office that I was in, and some people pick it up faster than others. But I didn't get it at the University of California in those days, and I was a classmate of Jerry McHugh's. I've heard that he's the one who started some of this, which I can't hardly believe, because I mean, if you go, because I think the education system today compared to what we went through is just 1,000 times more intense and more involved, and so much. I mean, the teachers and professors are so much more knowledgeable in an intellectual way than the people that I had at Berkeley, who, the only thing that we had going for us, which I thought was wonderful, is they let you kind of go your own route, and they didn't even care if you showed up, which is sort of the European system. But and that made more, I think, people maybe a little stronger in some ways. But the attempt today is much more intense, much more, I think. People care a lot about what they're trying to do. And if they're doing it, fine. If they're not, I don't know what to say. I mean, people are people. But again, I could say the profession could do, you know, try to really take on that responsibility. Give a little of your time and care, pay somebody and lose a little money in order to get these students along and educate it a little bit better in the practice. You can do it a lot better. I mean, God, they can learn so much faster. I know, we've tried it, and I know what they can learn. And we have good people. We have, we have project managers from major firms in LA who's, he's heading up the project, all of Ericsson's work that they've worked with Gruen. He's doing the Isozaki museum. I mean, he's a top-notch project management, project construction person. Well, he does his best, just as any of you would do, and he really works hard at it. But there's only so much time he can give, and I think he gives what he can to that in the education process. And we do have that potential here. We select from the community, and we pull people in on these seminars and lectures who are willing to spend that time. But we need it in the practice, that's all. I think that's the key, and I really think the IDP program as a model is fantastic. Probably too long. Also, we do have a Corbu lecture here at 6:30 if you want to hang around a little bit.
I'd like to just briefly summarize what it is that we've seen today. We've been to a school in a private university, a very undergraduate-based school, and seen a school in a public university, which is rather graduate-based. And of course, I think most appropriately, we came to Ray Kappe's school at the end of our tour. Now, tomorrow we'll give you time, tomorrow morning give you time to think about what we've seen, and it's been very educational for me, of course, but I hope certainly for you, and maybe shed some new lights on education and what this thing that we're trying to do really is all about, and who we are, and what we have to say as a profession, and what obligations we have to educators, and what it is that we want them to do for us, and what it is that we can do for them. And Ray and I go back a long way, and I've valued his counsel. He was a keynote speaker in 1977 at the convention, and he's been on the jury of the College of Fellows, and I think it's very appropriate, and I'm very proud to be a friend of his, and I thank him very much.
Thanks, Paul. Thanks very much. We didn't pin up around here or try to act like we were in front of the accrediting board. We just let it go as normal. Most of the students are gone. It happened today that there were a few thesis students who did pin up over in the graduate buildings, and also we're working on a project with NASA over there that might be interesting to you on capsule design in the graduate program. So if you want to wander out before you take off too, you could swing around past some of the shops and down into the building. I'll show you the way over there, and you can kind of just take a look at what's going on over there. It'll shake you up a bit. And, and anyway, thank you very much, and I enjoyed the day.
We also just one announcement. We want to thank Ray very much for the wine and cheese reception, which is on Ray, and a little applause. We do have a little bit of time. Our target for the bus departure is 6:30, so you do have a little time to look around and fill a glass of wine. Thanks.